There is a question children ask that quietly embarrasses most adults because we realize, trying to answer it, that we do not actually know how. What happened before the beginning of everything? What was there before there was anything at all? I want to tell you something that took me years to fully sit with, something that still, honestly, unsettles me a little every time I return to it. That question, as natural as it feels, may not simply be difficult to answer. It may not actually be a real question at all in the way we normally mean that phrase, because the very thing the question depends on, time itself, appears to have begun at the exact same moment as everything else. Today we are going to walk right up to the beginning of existence and find out why so many physicists now believe that time did not simply start ticking inside an already existing universe, but came into being alongside it in the very same instant. And if you want to keep exploring the strangest, most fundamental questions in all of physics with me, make sure you are subscribed, because I think by the end of this journey, the question, what came before the Big Bang, will sound different to you than it ever has before. Let us start with what the Big Bang actually was, because I think most people, understandably, picture it completely wrong. The common image is of some kind of explosion, a concentrated ball of matter detonating outward into an empty, waiting void that was somehow already there beforehand. That picture is not simply incomplete. It is, according to general relativity, backwards in a very important way. The Big Bang was not an explosion happening inside space. It was the beginning of space itself, and remarkably, the beginning of time along with it. Picture the surface of a balloon slowly inflating with small dots marked across it representing distant galaxies. As the balloon expands, every dot moves further from every other dot. Not because the dots are flying through some pre-existing space towards some pre-existing edge, but because the surface itself, the very fabric those dots are sitting on, is stretching outward, everywhere, all at once. Run that expansion backward, further and further, and the entire surface shrinks toward a single point. Not a point sitting somewhere within some larger pre-existing balloon, but the origin of the balloon's surface itself, the only surface that has ever existed at all. This is exactly what Einstein's equations show us when you run the expansion of our universe backward in time. In the 1960s, physicists Roger Penrose and Stephen Hawking proved something remarkable using this exact mathematics now known as the singularity theorems. Under quite general, reasonable conditions, general relativity itself predicts that our universe must have originated from a singularity, a moment where density and temperature climb toward infinity, and where the equations of general relativity remarkably stop working entirely, refusing to describe anything beyond that boundary at all. Here is the detail I think deserves the most attention because it is so often glossed over. This is not merely a moment where matter was extremely compressed. Space itself and time itself are described within general relativity as a single unified structure, space-time. Running that structure backward toward the singularity means running space and time backward together toward a boundary where the very fabric containing both of them appears to originate. Time is not a separate stage that this event happened upon. It appears to be part of the set itself, constructed at the exact same moment as everything performing on it. This is why physicists, including Stephen Hawking himself, have long offered a particular analogy that I think remains the clearest way to actually feel this idea, rather than simply hear it. Picture standing exactly at the North Pole and asking someone to point you further north. The question feels perfectly reasonable, the same way asking what happened before the Big Bang feels perfectly reasonable. But north, at the North Pole, is not simply an extremely difficult direction to travel in. It is not a direction that exists there at all. You have reached the edge of what the concept of northward even means, not because of some barrier stopping you, but because the very idea you are trying to apply no longer has anywhere left to point. Asking what happened before the Big Bang under this view may be exactly this kind of question, grammatically correct, emotionally intuitive, and yet built on a word, before, that depends entirely on time already existing in order to mean anything at all. If time itself began at that boundary, then before simply runs out of anywhere left to point, the same way north runs out at the pole. I want to be careful here because I think honesty matters more than a tidy ending, and this is genuinely one of the most unresolved frontiers in all of physics. The singularity theorems tell us general relativity predicts its own breakdown, but they do not tell us what actually happens at that boundary, because general relativity itself stops being a reliable guide exactly where we would need it most. Many physicists suspect that once you approach scales small enough, a region called the Planck scale, quantum mechanics must take over from general relativity entirely, and we do not yet possess a complete, tested theory of quantum gravity capable of describing what happens there. The honest answer right now is not that physics has fully solved the beginning of time. It is that physics has identified with remarkable precision exactly where our current understanding runs out. So here is where the first part of our journey leaves us. The Big Bang was not an explosion inside a pre-existing void, but the origin of space and time together, woven into a single unified fabric. General relativity's own mathematics predicts a boundary at the very start of that fabric, a boundary strikingly similar to standing at the North Pole and asking to go further north. And quantum gravity, the theory that might finally tell us what actually happens at that boundary, remains, to this day, genuinely unfinished. But unfinished does not mean physicists have simply given up and shrugged. Some of the most creative, mathematically daring proposals in modern cosmology attempt to describe exactly what that boundary might actually look like, up close, and what they suggest is stranger, and in some ways more beautiful, than a simple hard edge. That is exactly where we are headed next. Stay with me. We discovered that space and time were woven together at the very beginning of our universe, that general relativity itself predicts a boundary strikingly similar to standing at the North Pole and asking to go further north, and that quantum gravity, the theory that might finally describe that boundary, remains genuinely unfinished. Now I want to show you the most creative attempt physicists have made so far to actually describe what that boundary looks like, up close. In 1983, physicists James Hartle and Stephen Hawking proposed something they called the no-boundary proposal, and I think it remains one of the most genuinely elegant ideas in modern cosmology, even among physicists who are not fully convinced it is correct. Their suggestion was this. Near the very beginning of the universe, at scales small enough for quantum effects to dominate completely, the sharp, rigid distinction we normally draw between space and time may itself dissolve. With time smoothly behaving more and more like an additional dimension of space, the closer you approach the origin, rather than continuing to behave like the distinct, one-directional time we experience today. Picture, once again, that same North Pole we stood at during the first part of our journey. Every line of longitude on Earth, every north-south direction you could possibly travel, converges smoothly at that single point, without any sharp edge, without any jagged boundary, without any dramatic sense of hitting a wall at all. The pole is not a place where the surface of the Earth suddenly stops or breaks. It is simply the smooth, natural point where a particular direction, northward, gently ceases to have any further meaning. Hartle and Hawking's mathematics suggests something remarkably similar might be true of time itself, that rather than time slamming into a jagged, undefined wall at the Big Bang, it may curve smoothly into something behaving like ordinary space, the same way every longitude line curves smoothly together at the pole, with no seam, no crack, and no true edge anywhere to be found. Under this proposal, asking what happened before the Big Bang becomes not simply unanswerable, but literally analogous to asking what lies north of the North Pole, a question that fails not because we lack the instruments to measure the answer, but because the geometry itself has quietly, smoothly removed the very possibility of the direction you are asking about. I find something genuinely beautiful in this image, a universe with no jagged, violent starting gun at all, but a smooth, rounded origin, more like the gentle curve of a pole than the sharp edge of a cliff. I want to be honest with you because intellectual honesty matters more to me than a clean, satisfying story. The no-boundary proposal remains a serious, actively studied hypothesis, not a settled, universally accepted answer. Other physicists have proposed genuinely different pictures. Some suggesting our Big Bang might have been preceded by a previous collapsing universe in an endless cosmic cycle, others suggesting it might be one bubble among an unfathomable number of others, constantly forming within a much larger, eternally inflating background, an idea called eternal inflation, which some physicists connect to the broader multiverse concept we have touched on before in earlier journeys on this channel. None of these competing ideas have been confirmed through direct observation, and genuine, serious disagreement continues among the physicists working closest to this exact problem today. What I find remarkable is that this exact question, whether time itself could have a genuine beginning, troubled thinkers long before Einstein ever wrote down a single equation. In the 4th century, the philosopher Augustine wrestled directly with this same puzzle, considering the question of what existed before the creation of time itself, and arriving at a conclusion that feels startlingly close to what modern physics now suggests through entirely different means. He argued that the question itself may be malformed, that time was created together with the universe rather than existing beforehand as an empty stage waiting for something to eventually walk onto it. It is a strange, quiet thrill, honestly, to find a 4th century philosopher and 21st century mathematics arriving at such a similar shaped answer, separated by over 1,000 years and using completely different tools to get there. Picture a clock sitting inside a workshop and imagine asking what time it showed before the workshop and the clock along with it were ever built. The question sounds coherent only because we quietly, automatically assume some other clock must have been running somewhere else the entire time, keeping track of the workshop's construction from the outside. But if the workshop and the clock, and every possible way of measuring time at all, came into being at exactly the same single moment, there is no outside clock left to consult, and no meaningful answer waiting to be found, not because the answer is hidden from us, but because there was never a question there to answer in the first place. So, where does this leave us at the end of our journey together? We began by asking what happened before the Big Bang, a question that feels as natural as breathing. And we end by discovering that the word before may simply run out of anywhere left to point, the same way north runs out at the pole, the same way a clock cannot report the time before its own workshop existed. Physics has not fully solved this mystery, and I want to be honest that it may never fully resolve it in a way that satisfies every intuition we walked in with. But it has done something I find almost as remarkable, tracing our current understanding back to the very edge of meaning itself, and showing us with real mathematical precision exactly why that edge feels the way it does. Exploring the honest, unfinished frontier of where our understanding of reality actually stops is exactly why I do this work, and exactly why I wanted to walk through this particular journey with you. If this changed the way you think about the very first moment of everything that exists, then make sure you are subscribed so we can keep exploring these questions together. Tell me in the comments, honestly, does it feel more satisfying or more unsettling to learn that before the beginning may not be a place at all? Until next time, keep looking up and keep standing for a moment at the edge of the map,